Okay, this video is going to be on reintroducing proportional equations. The goal is you should be able to relate all parts of an equation like y equals kx to the situation it represents, and you should be able to find missing information in a proportional relationship using the constant of proportionality. So let's look at a situation involving concert ticket sales. A performer expects to sell 5,000 tickets for an upcoming concert. They want to make a total of $311,000 in sales from these tickets. Assuming that all the ticket sales have the same price, what is the price of the tickets? So if they want to make the $311,000, we would take the 311,000 and divide it by 5,000. And we do that because we want to take the amount and divide it by the number of tickets to find the price of one ticket. And we'd find that the price of one ticket would be $62.20. How much will they make if they sell 7,000 tickets? Well, since we know that our tickets, we would just take the 7,000 and multiply it by $62.20. And that would give us $435,400. How much will they make if they sell 10,000 tickets or 50,000 tickets or 120,000 or a million or X tickets, X being any number of tickets? Well, it doesn't matter which number you pick. You're always going to do the same thing. You're taking the number of tickets, in this case, let's call it X, and multiplying it by 62.2, which is the price. Or we could write it as 62.2x, where X could be any one of these prices or number of tickets. Let's look at recycling. Aluminum cans can be recycled instead of being thrown in the garbage. The weight of 10 aluminum cans is 0.5 kilograms. The aluminum in 10 cans that are recycled has a value of 20 cents. If a family threw away 2.5 kilograms of aluminum in a month, how many cans did they throw away? Well, to solve this problem, we could use what we know about the cans. So the one thing we know about the cans is that 0.5 kilograms is 10 cans. We could find 1 kilogram, which would be 20 cans, and then just build up to the 2.5. So if we said 2 kilograms would be 40, then 2.5 would be the combination of this and this, which would give us 50 cans. What would be the recycled value of those same cans? Well, we know we have 50 cans, and we know that it's 20 cents for 10 cans. Well, we could take the 10 and make it become 1 by dividing by 10. And to keep it proportional and balanced, we would divide the 0.2 or 20 cents by 10. And that would give us 1 can is valued at 2 cents. And now that we have 50 cans, we can multiply those together. And that would be worth $1. Write an equation to represent the number of cans C, given their weight, W, and then write an equation to represent the value R of C cans. So the answer would be C equals 20W and then R equals 0.2C. The way we can get this answer is by connecting the weight to the cans and therefore finding how much is 1 kilogram and how many cans you get. So we know that 0.5 kilograms would give us 10 cans. So if I find 1 kilogram, that would be 20 cans. So therefore 20 is what you multiply by the weight to get the number of cans. For the value, R equals 0.02C, you're doing the same thing. We know that 10 cans have a value of 20 cents. So therefore, if I found 1 can, it would have a value of 2 cents. And that 2 cents is what you multiply by the number of cans to get their value. In each equation, what did the letters represent? What did the number mean? So for our first equation, X was the number of tickets, Y was the cost of or total earnings they would make from the ticket sales, and the 62.20 was the cost of one ticket. For our next equation, W was the weight of the cans or the aluminum, C was the number of cans that you can make, and 20 was the number of cans you can make out of 1 kilogram. And then finally, on R equals 0.02, C was the number of cans, R was their value, and 0.02 was how much 1 can was worth in dollars. All of these are proportional relationship equations. Okay, proportional relationship equations look exactly like this. Y equals kx. Y is the right column variable in the table, or if the table is across, that would be the bottom. And x is the left column table of the table, or if it was going across, it would be the top. And then finally, k is the constant proportionality. Okay, k is the constant proportionality. And the constant proportionality, as we talked about, is the unit rate. How much per one? How much per one? So here are some equations, and based off of what we know, what you've seen previously, I want to see if you can figure out if they're proportional or non-proportional. Is y equals 4 plus x proportional or non-proportional? You can look at the equation or you can look at the table to help you. Well, it is not proportional. It is not proportional because if we look at the comparison of the y to the x over here, this would be our constant of proportionality. And the constant of proportionality is not the same for each set. So therefore, it has to be non-proportional. Is this proportional or non-proportional? This would be proportional. This is proportional because when we look at the constant of proportionality, which is the comparison of the y to the x, we see that it is the exact same number. Also, we can see that it has that classic y equals kx look in the equation. Is this a proportional or non-proportional equation? Non-proportional. Again, if we look at our table, our constant proportionalities are not the same. That's when we compare the x to the y, and we don't get the same number. And this doesn't seem to look exactly like our y equals kx. Proportional and non-proportional? This one is proportional. When we look at our constant proportionality, where we compare our y to our x, they're exactly the same. And though it doesn't look like it, it actually does have the same setup. In this case, we see division. But we could rewrite this as y equals 1/4 x. 1/4 x. Because dividing by 4 is exactly the same as multiplying by 1/4. So in actuality, this is proportional. Proportional or non-proportional? Not proportional. It doesn't have our setup. It does have the x, but the x is an exponent. And we look at our constant proportionality, which is looking at our y compared to our x, we don't get the same number. Proportional or non-proportional? This is not proportional. Again, we look at our setup. There are the y, x, and a number, but this has an exponent, which doesn't play a role in proportional equations. And we look at our constant proportionality, which is comparing our y to our x. We see we don't get the same number. So if we look at these two equations, which are formulas we can use, the one on the left is the formula for finding Fahrenheit from Celsius, and the formula on the right is converting inches into centimeters. If we look at these, what do you notice about the forms of the equations for each relationship? Which equation has a proportional relationship? And the answer is it's this one right here. The proportional relationship is of the form y equals kx, while the non-proportional is not. This extra plus makes it non-proportional. Here are some examples of proportional relationships. And again, it has that classic y equals kx. And you can have fractions as k, you can have whole numbers as k, you can have decimals as k. It doesn't matter. It doesn't always have to be y in the front. Whatever variable they have equal to works. And then this doesn't always have to be x. It can be whatever variable they choose in the problem. So let's talk about proportional equations from tables. Okay, proportional relationships are written in equations in the form y equals kx. Again, this is the constant of proportionality. This is what is in the left column, and this is whatever is in the right column of the table. Okay, finding constant of proportionality in a table. If a table represents a proportional relationship between x and y, then the unit rate is the constant of proportionality. The unit rate is whatever y is when x is 1. So if we look at our quarters and dimes situation, okay, it says how many dimes equal value of 6 quarters, how many dimes equal the value of 14 quarters, what value belongs next to the 1, what does the context mean, and what is the equation. Well, the number of dimes we get is 2.5. For 6, it would be 15. And for 14, it's 35. So, what is our equation? It's going to be y equals, since I'm going to call this x, I'm going to call this y. It's y equals 2.5x, because 2.5 is the unit rate. It is the number that y is when x is 1. So you just do y equals 2.5x. K is right here. Whatever 1 is in the x, whenever 1 is x, or x is 1, whatever that y is our constant proportionality. Also remember, if a table represents a proportional relationship between x and y, then the unit rates can be found by dividing any y by the x that is connected to. So in this one, we see 3 and 3k. Well, if I take the 3k and divide it by 3, I get k. If I take the 5k and divide it by 5, I get k. If I take the 400k and divide it by 400, I get k. If you take any point or any table, any part of the table, and take the y and divide it by the x it's connected to, you will get the constant proportionality. So we have this proportional relationship equation, y equals kx. Again, the right column is the y. The left column is the x, and k is the constant proportionality. In this case, if we're looking for it, time is our y, so we call it t. Distance is our x, because it's on the left. And then the 2.5, you can get that by taking any of these pairs and dividing it. 5 divided by 2 gives you 2.5. 10 divided by 4 gives you 2.5. 15 divided by 6 gives you 2.5. 20 divided by 8 gives you 2.5. This k, this constant proportionality, can be found by taking any y and dividing it by the x it is connected to. So we have this problem. A bakery uses 8 tablespoons of honey for every 10 cups of flour to make bread dough. So we have a table set up. How many cups of flour do they use with 20 tablespoons of honey? How many cups of flour do they use with 13 tablespoons of honey? How many tablespoons of honey do they use with 20 cups of flour? What is the equation for this table? So our answers would be 20, you need 20 cups of flour. 13, you need 16.25 cups of flour. And for 20 flour cups, you would need 16 tablespoons. So what is the equation going to be? Well, it's going to be y equals, where flour is the y and honey is the x, something times x. Something times x. So how do we find that? Well, we can pick any two numbers that we want. Okay? In this case, I'm just going to use 8 and 10. K is equal to the y over the x. Whatever the x is, whatever y is, and the x that's connected to it, I can divide. So I can do 10 divided by 8. And if I do 10 divided by 8, I get 1 and 1/4. Therefore, the equation is y equals 1 and 1/4 x. What is the equation for this table? Where a recipe says that 2 cups of dry rice will serve 6 people. Well, if we complete the table, we find that we get 1, 3, 2, 6, 3, 9, 12, 36, 43, 129, and x gives you 3x. So what's the equation? Y equals 3x. Okay? You get y equals 3x because if we look back and identify the unit rate, when x is 1, y is 3, then that is k. So the unit rate is 3. And if you take any of these numbers and substitute them in, you get the answer on the right. 2 times 3 is 6, 3 times 3 is 9, 12 times 3 is 36, and so on. What is the equation for this relationship in the table? All right, well, the equation could be, if I call this my x and that my y, we can call it y equals 0.5x. I get 0.5 by either looking at the unit rate, which I can find here, where x is 1 and y is 0.5, or I can get it by finding the connection between here and any number, where I could say k is equal to any y divided by the x is equal to. And if you did that for any of these problems, you end up with 0.5. All right, let's look at proportional equations from graphs. Okay, just a reminder, when we talk about proportional relationships in an equation, we've got y equals kx. Now, we're going to look at graphs, so we still need a table, or it can connect to a table. So instead of thinking of this as right column, left column, we'll think of this as, this is the y-axis. And this is the x-axis. Okay, k is still the constant proportionality, but we're going to see how we can find it in a graph. Finding constant proportionality in a graph. If a graph represents a proportional relationship between x and y, then the unit rate is the constant of proportionality. The unit rate is whatever y is when x is 1. So we use the same idea when we apply it to graphs. This graph comparing seagull numbers to the pounds of garbage they eat is proportional relationship. Graphs show proportional relationships if it's a straight line and it passes through the origin, 0, 0. What is the constant proportionality for this graph? Well, we can find the constant proportionality by looking at where x is 1, what is y? And in this case, where x is 1, y is 2.5, so 2.5 is our constant proportionality. But if a graph represents a proportional relationship between x and y, then the unit rate can be found by dividing any y by the x that it is connected to. So if we go back and ask what's the constant proportionality, I don't have to look at 1 to find it. I could use any point along the line. So for example, I could use this point here. Okay, points are y, x, y, like that. So therefore, 4 is my x, 10 is my y. If I take 10, which is my y, and divide it by the x, which is 4, I get 2.5. And k is 2.5. So if you take any point along the line and it's proportional, it should match up with whatever the unit rate is by dividing the y by the x. So what is the equation for this problem now? Well, it's simple. We know that k is 2.5, so we just put into the equation y equals kx, and the equation is going to be y equals 2.5x. Some t-shirts cost $8 each. What does the x represent? What does the y represent? Is there a proportional relationship between x and y? X is the shirts, or number of shirts. Y is the money, or the money earned. And is it proportional? Yes. And I can see that because I see there's a connection that the same number exists between here and here, between the x and the y. All right, so if we were to graph it, and this would be the graph of our line, what would the equation be? Well, looking at our graph, we know it's going to be y equals kx. So what is k? Well, I can take any point that I can easily read along this line, any point. So I could take 5 and 40. I could take 3 and 24. It doesn't matter, okay? Or I could even just take this one here, 1, 8, okay? Whatever one I choose, it's going to give me the setup to figure out what it is. So if I did 24 over 3, that gives me 8. Since the unit rate is right here, I could have just used that. In either case, we'd get y equals 8x. And that's the equation for that line. Let's talk about running laps. Is Han running at a constant pace, or is Claire running at a constant pace? And we find that it is Claire that is running at a constant pace. And because Claire is running at a constant pace, we can easily create an equation for this relationship. Since there is a clear constant proportionality, we can write that, and this is our x, and that's our y. We can say that time is equal to 2.5x. Sorry, 2.5d for distance. Now, we can maybe come up with an equation this, but it's not as easy. We're just talking about finding equations for proportional relationships. So it doesn't mean we can't find an equation for it. It's just that we're not learning that right now. Okay, coming back to Diego, May, and Lynn. What line goes with Diego? We found it to be the blue line, so this line here. And then what is the equation for that line? Well, the equation would be y equals 5/3 x, or y equals 1.66 repeated x. And we can get that by either going to the table and identifying the unit rate, which is right there. We could try to find the unit rate in the graph, but it's hard to find because they don't go by ones. So instead, what we can do is just look at any point, like this one here, which is very clear to us, of 30 and 50. And then we can just divide 50 by 30, and that gives us 5/3. And that is our constant proportionality, and therefore that is the K. What line goes with this table, and what is the equation for this? Well, the table goes with the red line. What's the equation going to be? Well, it's going to be y, and then we look for our unit rate, which is hard to see here. But if we took one of the points along there, which is 20, 50, we could do 50 divided by 20, and that would give us 5/2, or 2.5x. Okay, that is going to be the rate. And we can see in the table that is the unit rate. What line goes with this? Well, this one actually goes with the yellow line. And what is the equation for this? Well, even though it's not proportional, there is an equation that goes with it. It's just harder to look at or to figure out. But we can actually figure out. The setup for this equation is going to be y equals some constant proportionality, which is harder to find, or not actually that hard to find, plus something extra. And that something extra is where this line crosses the y-axis. Okay? But we know it's not proportional because it doesn't go through the origin. So right now you wouldn't have to worry about finding the equation. But if you did, you could do the same thing and take that point, one of the points. So it's going to be y equals, and if I do 50 divided by 40, which is a point along the line and it's straight, we would get 1 and 1/4. So I know it's 1 and 1/4 x. And then if I were to extend that line, I would find out what I'd have to add or subtract to get that answer. But we don't have to worry about that for now. Okay. The point on the graph represents a location of a ticket booth at a fair compared to the entrance. How far is the ticket booth from the bumper cars? Well, since 40 is the time and the distance is the y, it is 50 meters. 50 meters. Do the values in the table show a proportional relationship? How do you know? So I have 0, 0, which means that's good because it's going to cross to the origin. Then I have 20 and 25, 30 and 37.5, 40 and 50. And I can see that there's a connection between these if I just divide any of the numbers. So 50 divided by 40 is going to be 1.25. 25 divided by 20 is going to be 1.25. And therefore, 1.25 is going to be what the time would be distance if it was 1. What do the coordinates points on the graph show? Well, if I were to plot them, and it's a little hard to plot some of them, but I can do at least, I have 0, 0, and I have 20, 25. And if I kind of extended this down, it makes a straight line. And it's a straight line that passes the origin. So the coordinates show that this is proportional. what equation represents this relationship? Where do you see k, the constant proportionality, in the table, the graph, and the equation? Well, I can see right here in the table that the unit rate is 1.25. The equation is then going to be 1.25x, and there's the constant proportionality there. And then when I made my graph and I picked any number along that line or any point like this one, and I divided the y by the x, I find the constant proportionality again. So we can find the constant proportionality in the graph, in the table, and in our equation.